We start, Gustavo?
Yes, please.
Okay. Welcome, everyone. After this very short break, we go for the final strand of session number 5. It's going fast. It's going too fast. So we have now with us Laura Leonardi. And Laura, correct me if I am wrong. You are a researcher at INAF in Palermo, and you work for the development of innovative technologies for the diffusion of scientific culture. And Laura is going to share with us a project called StarBlast, a virtual reality tour of the outcome of stellar explosions. This seems super interesting, and so looking forward to listening to your presentation. So, Laura, please, the floor is yours.
Yes, thank you, Rosa, for the nice presentation. So I will share my presentation. Okay, can you see it?
It's perfect.
Okay, perfect. So, hi everybody. It's a pleasure for me to be here again after about 3 years since we first met in France. As Rosa said, I'm Laura Leonardi. I'm a fellow researcher and a scientific journalist at the National Institute for Astrophysics in Italy, working in Palermo, Sicily. On that occasion, I had the opportunity to present our 3D models about astronomical phenomena and objects in space. So today, I'm proud to tell you about the evolution of our experimentation, and I'm proud to present to you a brand new project called StarBlast. But before starting showing you the application, I want to give you an insight into what we're going to speak about through this trailer. So this project aimed to help students deeply understand the wonders of the universe. It was launched at the end of 2021 and was supported and founded by the co-section Pharos to promote the collaboration of the European scientific community in the field of Pharos scientific activities. And it was carried out in collaboration with CEFORMED. The application contains 3D models developed by the INAF Palermo Observatory and the University of Palermo's researchers. But before to start presenting this new application, it's fundamental to start from the beginning, because this project was born within another project started at the end of 2019 called 3D Map VOIR, an acronym for three-dimensional modeling of astrophysical phenomena in virtual reality. The aim of this project, the 3D Map VOIR project, is to provide the virtual reality viewing of 3D models of astrophysical phenomena and environment as the result of magneto-hydrodynamic numerical simulation. To do what? Just 3 examples. One, to interpret the data collected by international space telescopes such as Chandra or XMM Newton. 2, to investigate the physical and chemical properties of astronomical objects. And 3, to observe their evolution of the phenomena observed over time. It seems too cool to be true, right? But it works. Let's see how. Here you can see data from IDL of an astrophysical object. How can you tell anything? You can just see codes and codes. But if I turn this data into something that is visual, I can generate a simulation that I can analyze to interpret elements that are tough or even impossible to detect with traditional ways of analysis. So this is the aim of the project, the 3D map VUAR project. The use of these models allows researchers to present their scientific results more effectively, both for university students and the community of professional astrophysicists. But it's not all, because we immediately understood the potential of virtual reality also for educational and outreach purposes. So we start publishing these models on Sketchfab, which is a platform used worldwide for sharing 3D models used for augmented and virtual reality activities. Thanks to Sketchfab, we started to receive incredibly positive feedback and started a lot of collaboration all around the world, like the collaboration with NASA and their platform Voyager. NASA asked for some models that were then publishing on Voyager platform, made in collaboration with the Smithsonian Institution. As you can see, there are a lot of models, 9 in total, but 6 have been made by a team of researchers of the INAF Astronomical Observatory in Palermo, led by our researcher Salvatore Orlando. The models are these 1, 2, 3, 4, 5, and 6. The platform also allows you to download these models and print them in 3D for more inclusive research and teaching of astronomy. We just started using these print in 3D during public events. Of course, we didn't use them until now because of the pandemic, but we are planning to do an exhibition dedicated to studying and general public with poor sight. So I will inform you of this as we have new data about this. So this is us. As you can read, the team is composed of researchers and people involved in communication, education, and outreach, like me and my colleague Laura Daricello, who is also responsible for the activities for schools and the general public and communication at INAF and the Observatory of Palermo. Why this union is so important? Because not all the researchers can effectively communicate their results to general public, even if they are tremendous researchers in their field. They need a little help and support from someone involved in education and communication. Well, it's not the case of our team, because all the members are great communicators too, but we believe that science needs to be shared with everyone in a simple way. As I told you yet, the 3D map VUAR project grabbed a lot of attention by publishing 4 main collections of 3D models on Sketchfab. It's possible to interact with these models through a smartphone or a tablet. Even now, while I'm speaking, you can just scan that QR code and try to explore one of them. So can you imagine, can you feel the potential of this instrument? Anyone has a smartphone, anyone can interact with these models. So let's discover the collection on Sketchfab. The first collection we published is called Universe in Hands, and contains physical models that have been developed using sophisticated magnetohydrodynamic codes used in astrophysics, such as Flash and Pluto. What you see here is one of the first models that was uploaded, and we use this model for almost all our experiments, and it's the supernova Cassiopeia A. As you can see, interacting with the simulation, you can observe in details its composition and immerse yourself in the simulation to observe the detail closely. Another collection is the Art of Astrophysical Phenomena that collects 3D models that are the results of artistic reconstruction of astrophysical phenomena, scientifically accurate, based on what we know about this object. This is the Eagle Nebula, in popular culture also known as the Eye of God. Inside this collection that is called The Science of Science Fiction, you will find 3D models that represent scenes from science fiction films, such as Star Wars or Interstellar. And it describes what is scientifically realistic by illustrating phenomena and concepts of astrophysics. For example, one question, is it possible to find planets orbiting a black hole as shown in the movie Interstellar? If you can look at the models, you can find during this public event, we provide you the answer. And finally, inside the anatomy of astrophysical objects, models are representations that describe the structure of some astronomical objects. Here you can see, for example, the anatomy of a black hole. We believe that if you don't communicate, you don't exist. And the science not shared, it's science wasted. This is the reason why it's important to have an efficient communication program to grab people's interest and attention. For example, we use a green studio on several occasions to share these 3D models with the general public and students. Like this one, where during the pandemic, the first interactive virtual lesson is in streaming has been produced. The main actors of the educational process were the students who, through a computer or a smartphone, an internet connection, via video conferencing, or thanks to the use of a green screen studio, could leave their school and their homes, being teleported to become explorer of the universe, guided by, I'm sorry for the ambulance, guided by the researchers, okay, guided by a researcher who interacted in real time both with them and the 3D models to answer to all their curiosities. Here you can see a girl who connecting via teleconferencing. Now she will appear. And so during these events, feedback was incredibly positive and enthusiastic. People want to know and see more, but the models on Sketchfab had no explanations. They were just visually beautiful, but if you didn't have a researcher that explains to you what you were seeing, the communication failed. That's the reason why we decided to create this standalone app called StarBlast, a VR tour of the outcome of stellar explosion. This experience starts from our point of view. We see the Milky Way, so from the Earth, and then you can point to 5 objects in the sky using the joystick of your virtual reality headset. Here on the screen, you can see 3 of them. From the left to the right, we have the Crab Nebula, SN1006, and IC443. The other 2 objects you can visualize inside the app are the supernova remnants SN1987A and Cassiopeia A. The application is free, totally free, and to use it, you have to activate the Steam VR software, but we'll see how to use it, so don't worry. You can find the link to download the application by just scanning the QR code on the screen. During the exploration of the VR tour, a voiceover will provide short explanatory notes available in Italian, English, and Spanish to facilitate understanding to the general public, while a short bibliography will be available for further studies. And so you can make more in details about the model. The app can be used on 3 levels by different type of audiences. There is a playful level that allows the user to become a sort of explorer of supernova remains and pulsar wind nebula, navigating within these beautiful sources and appreciating the details in extremely engaging. Then there is a deeper level, mainly for university students, that allows them to grasp and touch literally, I would say, many of the physical aspects and characteristics of these extreme sources. They can be deepened thanks to the short-lived bibliography, as I showed you before, available for each object. And then finally, we have a final level for professional researchers. So the target at the moment are high school students, university students, and professional researchers. As we said when I presented the project at the beginning, the 3D map VUAR, using 3D models of these astrophysical objects, researchers can observe and analyze aspects that are difficult, even impossible to highlight with traditional analysis techniques. Sorry for my cat. Such as the distribution of chemical elements, the configuration of magnetic field, the complex morphology of the phenomena or the objects studied, and more. The app is compatible with the most popular virtual reality headset. It includes an online helper that can help the users in managing the controllers. They can be activated in any time. Online, people can find a video demo showing the starting point from the Earth and the selection of the object. Once users reach one of them, you can see their hands wearing these two red gloves and their fingers moving. This is the instruction to use the joystick. And then when you choose, you understand how to move, you can see your hand with these gloves. So then you can start the exploration, and that's all. It's so simple. Use it and tell us what you think. Okay, so before to conclude my presentation, I would like to remind you what are the useful steps to download and use the app. So first of all, remember the application StarBlast can be used only with the VUAR headset and a computer gaming. While, for example, what we publish in Sketchfab can be used with just a phone or a tablet. But for this application, you have to use a VUAR headset and a computer gaming. Then you have to activate the Steam VUAR software on your computer. Then after start the Steam VUAR, Steam VUAR can be downloaded online for free. So everything is free, of course. And here my contact, if you have any curiosities, you can find other educational resources. This is very important for us by visiting these sites, and especially Play INAF, where you will find lots of original resources aimed at different targets of students, from elementary school to high school, and all the activities are also translated into English, Spanish, French, and German, and of course in Italian. And here you can find a lot of activities dedicated to coding unplugged, robotics, making, and virtual and augmented reality. Thank you.